again. Thank you all for coming. I'm Nicole. So our next talk for Freethought Fest is Dr. Indre Viskontas. She's an experienced observer of human behavior, has published groundbreaking work on the neural basis of memory and creativity, and has won numerous research and teaching awards. Indre's work is characterized by innovation and a focus on the big questions of neuroscience. How do brain cells code memory? What memory processes enable creative thinking? How can the paradoxical facilitation of creativity emerge from a degenerating brain? Here today, Indre will be giving a talk called The Justifying Mind, The Origins of False Belief, where she will impart her expertise. Please welcome Indre Viskontas.
Thank you so much. Thank you, Nicole, for inviting me and the rest of the organizing committee for hosting this event. It's a great pleasure to be here. For those of you that don't know me, I wear two hats. I'm a neuroscientist, but I'm also an opera singer. And these days I work at the intersection of these two things, which you might say, where the hell is that, right? But in fact, both artists and scientists are after the same thing, to understand what it means to be human. And we just use different tools. So artists use individual experiences to illuminate what's universal, whereas scientists extract general principles that apply to everyone. So today I'm going to talk to you a little bit about what the science can tell us about why we believe strange things. But I'm also going to tell you from the perspective of an artist that sometimes when we look at the brain and we see that it's not quite as optimal as one might have liked to design it, there are still some really special things that come out of that make us human. So, a lot of times when you hear neuroscientists or philosophers or psychologists talk, they'll tell you how great the brain is. They'll say things like, you have more connections between your brain cells than there are stars in the universe. That's total bullshit. And I'm just going to call that out right now. With one of my favorite artists' memories of bullshit. You know what? Your memory is not a very good record of the past. Your decision-making is irrational. Your way of evaluating data is biased. And you're not even consciously aware of the vast majority of what your brain is doing. That's the sad part. But the good part is that you are really good at least one thing. And that is making shit up. And let me tell you about how this great human endeavor might have evolved. I'm going to speculate a little bit, but I'm also going to give you some case studies of patients that show us one way or another what happens when things go awry or when things are enhanced. And by looking at these patients and these amazing individuals, we can start to understand what is universal about this particular feat, being able to make stuff up. Alright, so let's start with some speculation, because I'm an artist, I'm allowed to do that, on that one hat. And so let's look at, essentially, a period of time during which probably there were a lot of selection pressures that shaped some adaptations of our current brains. So, around the time that we started living in social groups, our skull size expanded exponentially. Now, we don't know for sure, because we don't actually have bits of brain, they degrade. But we can make the assumption maybe that skull increase corresponded to an increase in brain, or at least a change in brain. So when we think about what were the selection pressures that were giving favor to individuals who then would pass on their genes to other individuals that might have, had this bigger brain, one idea is that, in fact, a lot of these selection pressures came from the difficulty of being with other people. This is called the social brain hypothesis, presented by Robin Dunbar back in 1992. And he suggests that, a lot of the things that we can do today are because we've had to navigate social interactions. And those interactions are difficult to navigate. So a lot of the great things that our brains do, that some of our primate cousins can't do quite as well, might have come from the fact that we need to navigate these interactions. In fact, some kind of interesting evidence that Dunbar has proposed is that the neocortex, or the newer, evolutionarily speaking, part of your brain, That ratio with the older part of your brain correlates with how big your group size is in your primate family. So the bigger your primate family, the bigger this ratio. So again, we see a little bit of maybe some evidence that social interactions are somehow shaping where our brains are today. Now we can do experiments and we can look at what happens when rodent brains don't have social interactions and how the lack of social interaction affects the neural development of a brain. But even before we get to social interaction, we know that an enriched environment shapes development in profound ways. So here's the neuron of a mouse that was raised in a standard cage, pretty boring, and then there's a neuron of a mouse that was raised in an enriched cage, with lots of fun things to do. So you don't need to be a neuroscientist to see that these two neurons look very different. What's different about them? The one on the right has potentially more connections that it can make. Now, connections are a big theme in neuroscience, and let me tell you something really poetic about the brain. As your brain is developing, when you're born, your brain is about maybe 350 grams or so. In the first year of life, it almost triples. So by the time a child is 1 year old, their brain size is about 1,000 grams. For the rest of their development in adulthood, they only gain maybe 200 to 400 grams. So there's a lot of stuff that happens in that first year, of course, but all the other changes, the things that differentiate you from your 1-year-old self, primarily has to do with connections. Here's where the poetry comes in. Any neuron that doesn't make meaningful connections, that is, it doesn't get signals and send signals, dies in this process. In fact, when this process of pruning goes awry, we have some pretty awful brain diseases that can start to occur. So this pruning process is important for a healthy brain, and it also suggests that there's no such thing, by the way, as the fact that we only use 10% of our brains. There's a lot of reasons why that myth doesn't hold water, but one is that neurons that don't make meaningful connections die. So the more meaningful potential connections that you have, presumably the more complex your brain can be. Let me show you another example. If an individual is raised in social isolation, we know that this can be devastating to human beings. Just giving a plant to an elderly person in hospice prolongs their lifespan, and it's a plant. We can see children who are raised in social isolation. What I'm thinking about are some of these horrible orphanages in Romania, in which they never develop properly if that critical window closes before they have that social interaction. It has a profound effect of how their brain develops and what possibilities there are for them in the future. Now here are two neurons. One was raised in isolation, and the other on the right was raised among other social beings. And you'll see also there's this pretty profound dendritic branching, this proliferation of connections that happens when the neuron is in an environment where the individual who hosts that neuron can interact with others. This is in a fish. So imagine if we can see this in a fish, what the effect will have in our own brains. Okay, so hopefully I've told you now that social interaction is important for brain development. It seems to have been a driving force in our evolution. We think, we can't prove that, but it's kind of a compelling story. And we know that individuals who have better social cohesion maybe survive better. And one of the things that social cohesion allows for is the proliferation of false beliefs. Because oftentimes, social cohesion is glued together by a shared belief, particularly if you are in a community in which you feel necessarily persecuted. Then all of a sudden, you find other people who share your beliefs, and now you can find a social connection with those people, and you can have social bonding. So those of us with better social skills around the time that evolutionary forces were really changing our brains thrived better, perhaps. We survived better, and there you have it. Communication became incredibly important, of course, and our brains were shaped as such. But there was something else that happened in our evolution that, is part of this story, and that is that we discovered ourselves. Self-consciousness came on board, but it came on board relatively late. Again, I don't know how a frog talks to himself, but I'm assuming that the frog doesn't have quite the same self-consciousness that I do. We certainly can look at animals and how they develop what we call a theory of mind. This is this notion that another being has intentions and beliefs that are different or perhaps the same as yours. And we can do things like the mirror test, where we put a red mark on the nose of an elephant and then show the elephant a mirror and see, does the elephant actually try to touch his own face, knowing that he's looking at the mirror, or does he look at the other mirrored individual? Now, there are a lot of problems with the mirror test, because some animals, for example, certain species of primates, won't even look in the eye of the thing in the mirror because that is an aggressive act. So because they fail the mirror test, not because necessarily they don't have self-consciousness, but because they simply won't look long enough to notice that the thing in the mirror is actually themselves. So the mirror test has its problems, but at least we can assume that for the most part we certainly pass the mirror test. And there are times in our developmental progression as children where we go from failing the mirror test to actually passing the mirror test and developing this notion of this idea that we are independent selves. Unfortunately, this self-consciousness is just the tip of the iceberg when it comes to all the computations that your brain does. And yet it doesn't feel that way. Our inner world, our inner monologue feels as if that's what we mean when we think about thinking. Often that's what people equate with their own souls or their own entire identity and consciousness. But in fact, you're only conscious of a very, very small number of all of the things that are going on in your brain in parallel. So here we have a condition in which we are fooling ourselves into believing that we are actually pretty good at understanding our own thinking processes, if those thinking processes include all of this unconscious work. And yet, there we are. So, how do we understand then what is the relationship between this self-consciousness that evolved and all this other stuff, and how that relates to the proliferation of false beliefs? Well, here we need to look at another foundational principle of how the brain works, at least the human brain. One thing that the human brain does a lot, and I don't even know necessarily that it's very good at this, but it certainly does this a lot, is look for patterns. In fact, we'll err on the side of finding a pattern, especially a meaningful one, where there really isn't one. This is especially prevalent in pareidolia, where we see, and primarily faces. Faces are really important to us. Understanding each other's faces and expressions and stuff, and that's something that is really important to human beings. And so we'll see faces where I guarantee you there actually aren't any. We'll err on the side of finding a meaningful pattern rather than potentially missing something that could lead to some kind of information. So that's true in the visual world, you might say, but maybe it's limited to the visual world. But here I am to tell you that we do the same thing when it comes to a series of events. Here's another problem that we do. We infer causation when two things happen at the same time because we want them to be related to each other. We don't like the idea of coincidences. That's scary. That means the world is random and chaotic and unpredictable. But if we can attribute a cause, then we can understand what's happening. So I'm going to show you a little video of what I promise to you is just a series of shapes. There is no meaning in what they are doing. And yet I guarantee that by the end of this 1-minute video, you will have a story forming in your brain that includes characters, a beginning, a middle, and an end, and potentially even a climactic, suspenseful moment. This one? It's just shapes. And yet we have a hero who's protecting his friend, we have a bully who's being mean, and so forth. And very, very quickly and we've constructed a narrative from a series of events. And in fact, one of my colleagues, Biederman at UCI, has this idea that one of the reasons we seek these meaningful associations is because it's actually a little bit rewarding. So he points to the fact that we have more endogenous opioid receptors in our cortical association areas than in our primary sensory areas. And he implies then that it is pleasurable to find these associations. Well, we certainly know that this kind of storytelling is engaging. It's why we all do it. It's why it's everywhere in the world. So here we have the foundations of why we might be more prone to believe the things that aren't true. So we see patterns where there aren't any, we have self-consciousness, but it's just the tip of the iceberg. But what about this idea then that the actual proliferation of false beliefs comes from the way in which these two foundational principles perhaps interact? And to illustrate that point, I want to turn to a group of patients that have taught us a lot. These are patients who have a memory problem. So they can have a memory problem for a number of different reasons. Sometimes it can be Alzheimer's disease. Sometimes it can be something called Korsakoff syndrome, which happens when a long-time alcoholic doesn't get enough thiamine in his or her diet and develops degeneration of the middle part of the brain that is related to forming new long-term memories. It happens sometimes in the other kinds of patients. But what I'm talking about is a patient who not only has trouble with his or her memory, but also confabulates. So they don't know that they don't remember. Instead, if you ask them about what happened last weekend, they'll tell you a story. Like, you know what, last weekend, I took my kids to the zoo. We went to the zoo, we saw the giraffes, and then go into an elaborate story. And then you start calling them out on it. You say things like, but, sir, you were in the hospital last weekend. So how did you get out of the hospital? And they'll find a way to make it sort of make sense. And then they'll say, but your children are of adult age. So did you really take them to the zoo? And again, some more details will come through, and maybe the person will get a little bit confused, but they won't question the fact that their memory is weak. And they have what we call confabulation. My old mentor at the University of Toronto calls it honest lying. They are honest about it. They really want to tell you what it is that they remember, and they kind of make up this story about it. What these patients illustrate is something fundamental about how we all remember. So it's not just that their brain is degenerated, their memory, the way they remember is changed. What's happened is that their fact-checking has gone awry. So most of us, when confronted with this kind of evidence, can say, oh, you know what, you're right, maybe I don't quite remember. In these individuals, they have enough damage to parts of the brain that are involved in sort of fact-checking their memory that they can't really do that automatically. But we all do a type of confabulation when we actually have these memories, and I'll show you how that works in a minute. But first I want to get to some research that tells us a little bit about how this confabulation might come around. And in order to introduce this work, I want to dispel yet another myth about the brain. This is the myth that the left side of your brain is logical and the right side of your brain is flighty and creative. Total myth. If you still think that this is largely true, let me show you how the parts of your brain from the left to the right are connected. Notice how there are many more connections connecting the two hemispheres than within a single hemisphere. So if it's true that your right brain is creative and your left brain is logical, it really doesn't make any sense because in fact the front part of your left and right brain is talking much more quickly and effectively than the left front brain and the left back brain. So in fact, just in the way we look at neuroanatomy, we know that this can't be true. Where this information came from was patients in which this major tract, the corpus callosum, was cut surgically. Now you might think, why would anybody cut the corpus callosum? It's beautiful. It has all this kind of communicative power. Well, it's because in these patients they had epilepsy. And epilepsy essentially is the firing of neurons gone awry. And when neurons fire out of control like that, they actually create a toxic place in the brain and there can be neuronal death. So we want to limit the amount of this fire of seizure activity spreading. Now we have better drugs to do that, and we have other ways, although we still do some neurosurgical resections when the drugs fail to work and when the patient what it's called for. But early in the, well, I would say the mid-20th century, there was a series of patients that had their corpus callosum cut in order to stop the seizures from spreading from one side to another. Roger Sperry, Michael Gazzaniga did a lot of this work. In fact, Michael Gazzaniga became known as the father of cognitive neuroscience as a result of this work. But why am I telling you this? I'm telling you this because something that he found out from these patients is really interesting. And it tells us a lot about how our own brains function. So in order to understand his findings, we first need to understand how do we test these patients. Now we have a patient who has a left hemisphere intact and a right hemisphere intact, but those two hemispheres aren't communicating the way they are with you and me. If you meet this patient for the first time, you probably won't know that anything is awry until a few minutes into the conversation you might notice a couple of odd behaviors. But the truth is that these patients compensate for the fact that they're not getting information into both hemispheres. So the way your brain is wired, the left side of your visual field actually is processed by the right side of your cerebral hemispheres, and the opposite is true for the right side of your visual field. So these patients, if given the chance, will look at something with both sides of their visual field so that both hemispheres are getting the information. Now, if we want to see what one hemisphere knows or does and in isolation, we actually need to tell the patients, look, just look straight ahead and we'll just flash something into one field of view before you have a chance to move your eyes and see that with the other hemisphere. So that's what they do. So here's an example of how this might work. You might have a series of words in front of the patient and they're fixating in the front. What's going on in the left side of their visual field is entering the right hemisphere. What's going on in the right side of the visual field is entering their left hemisphere. And then they can't see their hands. Their hands are behind a screen. And they're asked to choose from a series of items. Now here's what we do know. And this is partly where this myth about left logical, right creative came in. The left hemisphere is where, for most of us, language is localized. So our right hemisphere does have language. It can talk a little bit, can understand language, but not very well. You can think of it as, maybe like a 1.5-year-old child who can have, has a few words, but can't really talk in, nice long sentences. But the left hemisphere can talk. So if you ask this person, what do you see? He'll say, I see a ring, right? Because that's coming into his right visual field, it's going into his left hemisphere. And that's all fine and good, but with his left arm, he'll pick up a key as opposed to a ring. Why? Because his right hemisphere is seeing the word key and reading that and deciding that that's what it wants to choose, so it doesn't take the ring, instead it gets the key. Now here's where the interesting insight came in. This is all, okay, expected, but when Michael Gazzaniga asked him, why is your left hand picking up a key? They would start to make it up. They would say, I don't know, maybe I was thinking about a key ring. Or maybe I was just thinking about I lost my keys this morning. Or they'd sort of start making up a story, justifying their behavior. And this is where Gazzaniga understood that, in fact, in the brain, there is an interpreter. This interpreter watches what's happening, doesn't always have the right information if it's a person with that we call split brain. But the interpreter interprets. That's its job. And you know what? We all have one. If you think this is restricted to patients with corpus callosum, well, let me tell you that's not true. And we've known that since 1931, when another psychologist was studying insight, trying to figure out how do we get that aha moment where all of a sudden we solve a problem. So he had people try to solve the problem. The problem was you had two ropes hanging in a room, and they were just far enough where you couldn't hold on to each one of them and then tie them together. Your task, of course, was to tie them together. And then there was a series of tools on a little desk that you could choose from to accomplish this task. Now there are a couple of, boring solutions to this task. You tie one tool, then you attach to another tool, you go, okay, that's kind of boring. But there is one kind of relatively insightful or creative solution to this task. Has anyone figured it out yet? Yes? Stand on the desk. Okay, it's not that creative. Anyone have a better answer? Pendulum! There you go. How did you come up with the solution of pendulum? You saw a hammer. All right, well, you're all right, but I think you're all lying. I think class before, maybe not. Yeah, little nods. So in fact, that is the creative solution. Take a hammer, tie it to the end, swing it like a pendulum. And it turns out that when the psychologist was doing this experiment, no one came up with this solution spontaneously. And as psychologists do, he would get a little frustrated and bored with his participants, so he'd walk across the room and subtly set the rope swinging. All of a sudden, there was an aha moment. And then he would query people, well, how did you come up with the solution? And none of them said, oh, it was because you set the thing swinging. No, they make up all kinds of stories. In fact, let me read you one explanation that was given to him. All right. Having exhausted everything else, the next thing was to try to set it swinging. I imagined monkeys in a jungle jumping from vine to vine. This was a psychologist, by the way. So even the psychologist who should know better did not know any better, and in fact made up a story of how they actually figured out the solution. So this was in the 1930s. So you might think, well, we've evolved since then. Certainly this isn't true, but I could give you study after study after study that shows that you make all kinds of decisions and you justify them in ways that have nothing to do with why you actually made that choice. For example, in the 1970s, Nesbitt and Wilson had a very famous study where they were trying to sell pantyhose to women in a department store, and it turns out all the pantyhose laid out on the table were identical, but people tended to buy the ones on the right-hand side, and tell you why. All kinds of silly stories, like different color, different texture, they're all the same. So now you know why, when you go into a department store, there is actually a very strategic selection of clothing in different areas. It's called the right word bias. But even beyond that, there is a justification that we make even when it comes to things that you think we actually are pretty, have pretty good reasons for it. Like, for example, choosing someone that we're going to date. Now, especially with the advent of online dating, we all think that we actually are pretty rational about this decision. So to test this, a number of Scandinavian psychologists used sleight of hand. So they showed initially 2 images of, this was to heterosexual participants, unfamous faces from the Sterling database, and people had to choose which one they wanted to go on a date with. So they would choose either the left one or the right one on each trial. Now, in about a third of the trials, and then after they made the choice, they would have to say why. Okay, I chose the one on the right because she had nicer hair, or she reminded me of my mother, or whatever. Then, in a third of the trials, there was sleight of hand, and people had to justify the choice they didn't make. And most of the time, they didn't even notice. And they justified this particular choice in a number of different ways. Like, for example, she has earrings. I like earrings, but the one you rejected is the one that had the earrings, right? I thought she had more personality in a way. She was more appealing. Here's one who was honest, and then, I don't know, exactly, because you didn't make that choice. So we have this sense of interpretation and justification of our own memories. So we even see that this justification can extend to things that aren't necessarily conscious. One test that we have for individuals with memory disorders is called the Ray-Osterrick figure. So it's kind of a complicated figure. The first part of the task is just to copy it, to see whether you have visual spatial skills intact. And some patients, already have trouble copying, but for most of the part, if you don't have visual spatial deficits, you can copy it relatively well. Then we take it away, and we wait 10 minutes, and we ask you to draw it from memory. Now, of course, all of us are going to make some errors to this, right? It's not a perfect rendition, but individuals with real memory impairments make much larger errors than those. Most of us would probably take, when we take it away, we still draw something that resembles this a little bit. Let's look at patients with Alzheimer's disease. On the top row is the copying diagram. So you can see how sometimes they have a little bit of trouble copying, but their copying isn't that bad. They certainly saw the stimulus. And then when asked to draw from memory, something very different happened. They don't remember anything about the fact that this was just a weird figure. Instead, they remember the gist, and they make meaning out of it. Faces and houses, 2 things that are very meaningful to us. Why does this happen? Because even in the healthy brain, remembering is not like a filing cabinet. We don't encode a whole bunch of information, write it down into a diary, set the diary into the filing cabinet, and then when we want to retrieve it, just pull it out and read what's on the diary. Instead, every time we pull out that diary, we have to rewrite it. That's how memory works. It's reconstructive. It's an active process. And in fact, your current beliefs, whether they're political or otherwise, your mood, your context, affects how you rewrite that particular memory. So remembering is a constructive process. I can even show you how this happens in the brain. You get a series of perceptions, they activate certain parts of your brain, and there's a part of your brain called the hippocampus that takes note of all the things that were happening at the same time. We call it a convergence zone, and it lays down a little tiny schema of those particular items. So that in the future, let's say you see me somewhere nearby, that's serves as a retrieval cue. Essentially what that does is it tells the hippocampus, hey, there's this one thing that seems kind of familiar, let's recollect the entire memory associated with this person. What the hippocampus then does is it reinstates the activation in your cortex that was happening while you were encoding the memory. Notice how active this process is. It's not just like your brain is triggered and you get this whole, you actually have to do work. Essentially brains have to do work in order to reconstruct all these different details of the events. And I don't need to start talking to you about how this process can go awry. But what happens when this process is actually really pretty good? Are there individuals who can actually remember critically everything that happened to them in the past? This sounds kind of far-fetched, and sometimes we hear these stories. Oh, I can remember what I had for dinner on March 3rd, 1982. Really? Well, it turns out that a handful of individuals do have superior autobiographical memory. Let's hear how that might work.
It's often said that we are our memories, that web of experiences, relationships, thoughts, and feelings that make us who we are. We don't remember it all, of course. That would be impossible. Or would it? There's been a discovery in the field of memory recently, so new you won't find it in any textbook. So hard to fathom, there are some who remain unconvinced. For the moment, the scientists studying it are simply graphical memory. And unless you happen to know one of the handful of people discovered so far who have it, get ready to be amazed. Louise Owen is 37 years old and a professional violinist living in New York City. But she has another gift too, one that is far more rare.
Let me give you a date. Let's say January 2nd, 1990.
Right now I'm remembering the jogging class that I started that morning.
And you're actually back there.
I can feel it. I can remember the coach saying, keep going.
That was more than 20 years ago, when she was 16. A date I picked completely at random, as I did this one.
February 18th, 1988.
1988. Oh.
You're laughing.
I'm laughing. It was a Thursday. I had a big conversation with a friend of mine, and that's all I'm going to say.
Louise says she can remember every day of her life since the age of 11.
Try to talk us through, can you do that? How it works out of the air. April 21st, 1991.
1991. Okay, April 21st. So in the moment between April 21st and 1991, I have scrolled through 25 April 21sts, thinking, which one is it going to be? Which one is it going to be? Okay, 1991, which was a Sunday. And I was in Los Angeles, and I had a concert with the American Youth Symphony.
You went to the most important thing.
Right, that was the most, I mean, I really don't want to hear about, sort of the day, although I got up in the morning and I got dressed. And
Yeah, I remember that.
Yeah.
You remember what you had for lunch?
Not what I had for lunch that day, but I do remember what I had for dinner the night before.
And effortless. It just pops in.
I mean, for me, it's almost as automatic as if you say, what is your name and where do you live?
But how do we know that what she says she remembers really happened? Enter James McGaw, professor of neurobiology.
Stop this. All right, so yeah, how do we know, right? It's kind of amazing. I don't remember what I had for dinner 3 weeks ago, let alone 20 years ago. So of course we can test certain things. We can give them a whole bunch of 10 random dates, and we can see how they do. Here on the bottom in the colored bars, that's how you and I would do on this particular test. The first set of columns is the day of the week. The second is verifiable events. The third is autobiographical events, and then finally a total at the end. Almost perfect. Almost perfect. And this is just a small group of individuals. In this particular study, I think they found 11 of them. So, that's not a lot of people, but they actually are able to do this. And how does this work, and how is it possible that it's so different from where we are? Well, did you notice what she did? I'm scrolling through 23, I don't remember which date she was talking about, right? She's scrolling, it's very different from how you and I remember. And in fact, it's a little obsessive, don't you think? And in fact, if you look at the correlation between obsessive behaviors and the consistency in remembering in these individuals, we actually see a pretty strong correlation. They obsess about their memories. And when you ask them to perform other tests of memory, like working memory, which is holding and manipulating things in mind, they're not any better than the rest of us. They're only really good at this particular type of remembering because that's what they do. In fact, they often talk about how their obsession with their memory prevents them from living a life the way that you and I would. They become obsessed, and they organize their memory. So, I can show you another little video but I'm running a little short on time, of how they actually, how this obsessional behavior correlates with how they remember. But let me get to the point, which is, if you look at the number of details that these individuals remember, the yellow circle are the patients or the individuals with superior autobiographical memory, the blue is the control, and then we have the passage of time. It turns out that we actually start out encoding pretty much the same number of details. And what's happening in these patients is an absence of forgetting. Not an encoding of more details, they just don't forget. In the course of we pretty much forget most things that are irrelevant, but they don't. They remember all of these details because they obsess about them, because they categorize them, because they organize them, they do things with them. We don't. We just extract the things that are important and let go of the peripheral details that aren't important. And in fact, if you look at their memory for the gist of what happened, this is where we are superior and they are not. So they actually can't extract the regularities in the environment because they're so stuck in on remembering the details. So, this takes me to how our memory actually works. Details are favored over gist in these individuals, but for most of us, we favor the gist. In fact, as we tell stories, whether they are about, how we're trying to justify the beliefs that we have or what have you, our stories change with each retelling, right? There's a great set of experiments that show, the original drawing and then all people's memory of that particular drawing, and there's a little bit of similarity, but even sort of the actual content of the drawing has changed. And so, in fact, what we remember is the pattern over time, the gist, sort of important things. This is why you can hear a story over and over and over again and still continue to enjoy it. This is why this idea that spoilers actually spoil stories is not held up in evidence. In fact, when we ask people to rate how pleasurable a particular story is, if anything, the trend is for people to say that the spoiled stories, even if they're ironic twists, are more enjoyable than the unspoiled stories. We enjoy going back through this progression because we don't remember the details. So now we have a memory system that isn't very good at remembering the details, but can extract the gist. It's reconstructive, coupled with a kind of intuitive desire to find patterns, even if there aren't any, coupled with an interpreter that makes up a story about what it is that's going on in our brain, and what does all this have to do with being human? What does all this have to do with some of the good things of who we are? Well, let me tell you about one more set of patients. These are patients that have hippocampal damage bilaterally that can't form new long-term memories of facts and events. They're stuck in the present. They can't recall the past, but they also can't imagine the future. If you ask them, what are you going to do a week from now or 3 weeks from now, they actually don't know how to answer that question because they can't even imagine what that future is. And when we look at the parts of the brain that are involved in elaborating on past events, remembering past events, and those that are involved in imagining future events, we see almost an entire overlap. Patients who have damage to this can't do this future imagining, but we can, because our memories are constructive. So, taking this way of remembering that's reconstructed, adding the interpreter allows us to imagine the future. And of course, that imagination can include things that aren't based in reality. So let me leave you with the take-home message. We evolved in a time when living in social groups was important. So a lot of the things that shape our brains include things that shape social cohesion, including things like sharing beliefs, whether or not they might be true. We see patterns where there aren't any, as long as they're somewhat meaningful to us, like faces or a grumpy cat. Our consciousness is just the tip of the iceberg, and yet we've evolved an interpreter to make us believe as though we have access to all the different things that our brain is doing, when in fact we don't. Finally, we remember the gist, not the details, but that is what allows us to imagine. Thank you. Yeah, so I have a couple minutes if there are any questions. Yeah.
I have heard of talking about that 60 Minutes.
Uh-huh.
I heard it being referred to as eidetic memory. Is that from?
Yeah, so eidetic memory we think of as more like what is the equivalent of photographic memory. So photographic memory is this notion that actually you can see things that either you observed or experienced in the past, like almost like a visual snapshot. And so we can test eidetic imagery or eidetic memory by giving you a series of numbers in a matrix. Okay? Now, if you have photographic memory, you should be equally fast at remembering those numbers in any way, like whether it's a spiral or from bottom to top or from top to bottom. You should be equally good at telling me what those numbers are, no matter how I ask you to do it, because you can just pull it up into your mind's eye and go through it. And it turns out that we've never seen a case of a person passing that test. That photographic memory, there's no evidence that it exists in that way. People are always faster at responding with those numbers in the way that we encounter them, which is reading them essentially from left to right and so forth. So anytime we've tested people's ability to show us that they have photographic memory, they've failed. Even though people like Bill Clinton, for example, claims that this is how they remember, again, I think it's a function of the interpreter. I think they have superior memories, but I think it's not the way that they think it is, that it works.
In 60 Minutes case and other stuff that I've read, it only indicates there's the tests that are being shown is what do you remember about this particular thing. Is there any other kinds of memory comes up rather than I know what I ate on February 25th?
So that's the point, right? And you can see this in other mnemonists. People who are chess grandmasters, for example, have really great memory for chess pieces on boards that make sense. But if you ask them to remember pieces on a chessboard that it doesn't make sense within a game context, they're not very good at it. Individuals who can recite the digits of pi are really good at reciting the digits of pi, but not necessarily other feats of memory. These individuals are really good at remembering things, dates, and what they did on those dates, but they're not very good at other types of memory. What this suggests is that this memory skill is a skill that is developed through training, through habit learning, and you can train yourself to develop that kind of mnemonistic skill. So there's a great book by Jonathan Foyer called Moonwalking with Einstein, where he describes how he tried to become a mnemonist, and in fact he did. Within a year, he won like some American national numbers and everything. In any case, we can train ourselves up, and the argument with the superior autobiographical memory, I mean, we often think about memory as autobiographical memory. Most of us don't think about memory as learning how to ride a bike. That is a form of memory. But we think about, can you remember what you did on your 5th birthday? For most of us, that seems at the core of what remembering is all about, but it's just one part of it. And these individuals obsess about that one part of it, and they become highly trained on that one part of it. But it doesn't transfer to their other ways of remembering.
Can you take one more?
Okay. Yes.
How does science explain people who have been living their lives one way and they have some dream and they wake up evangelical?
Okay, it's a good question. I have to look at the case themselves, but certainly there are examples of individuals who, for example, have had a bump on the head and woken up with visions and an extremely religious experience. So there are a lot of reasons why this might happen, but one is that there actually is a part of your brain, it's in the right hemisphere in your temporal lobe, that seems to correlate with religious experiences. And in fact, individuals who have seizures that include this area, more often than not, report having a visual experience that is religious. So I saw, the Virgin Mary coming down and so forth. So sometimes you have to look at what was happening in that, moment. seizures don't necessarily need to look like when someone's on the floor having a grand mal seizure. That's not actually how a lot of seizures look. Sometimes seizures just look like a person spacing out for a couple of minutes. So that there is a relationship between temporal lobe epilepsy and the development of these kinds of religious feelings. But of course, there's a lot more to that, right? That's one example of how a brain change can elicit a religious experience, but that doesn't mean that there aren't a number of other pathways in which this can happen. So of course, there are all kinds of sociocultural things that don't necessarily need to involve a acute neurological event that can lead to this kind of experience. But yes, there are a lot of ways in which experiences can be interpreted too as religious. So there's a lot of work on, for example, near-death experiences and how near-death experiences have certain patterns that people respond. But there's also a lot of evidence that how people interpret those experiences is based in the religion in which they are immersed. So, for example, people who are Christian and they have a near-death experience, they'll see demons and angels. An individual who is of a different religion will see a very different endpoint and interpret it that way. And then we can talk about, well, what are the symptoms of near-death experiences? Well, it's essentially the brain losing oxygen, so there are a whole number of visual things that can happen. There are a whole number of other experiences. We can talk about the details of those particular symptoms and reduce them that way. But ultimately, it seems like the point is that how we interpret those experiences. Remember, our perceptions are so highly processed by our brains. They're not veridical. And even if you just look at, we look around the world and we think everything is in focus, but in fact, just a tiny part of your visual field is in focus. Test this, take your thumb and put it just to the left or right of it, and you won't be able to read a word that is printed on your thumb, even if there isn't one printed on there. It's blurry for the most part, and yet we don't experience the world that way. So that's sort of the point that I make, is that our interpretation of how the world is very much tied to things that aren't necessarily based in the actual physical world outside of it. Thank you.